All right, so I'm gonna go over 4.9, 4.10. I'm gonna introduce oscillation, I mean resonance, uh, resonance in 4.10. So basically, we're gonna study free mechanical vibration. So no damped, uh, damped. Sorry, it's damped, but no external force. So damped free mass spring system in 4.9. There are three cases: under damped, over damped, critical damped. Under damped means that the vibration is restricted by damped because the damping force. So damping force is larger than uh, the uh, the uh, the spring force. So we're not going to expect that there will be the motion of vibration in this case. In the second case, over damped, which means that the spring force is larger than the damping force. Okay, so we'll see that there is the oscillation in this system in this case. Okay, and then critical damped is a b squared equals 4. B and 4 mk here. The b is the damping constant, k is spring constant in Hooke's law, and the m is mass. So when you find out the characteristic equation, then this type and number of solution of the characteristic equation will be determined by this, right? The discriminant. So b and 4, if b squared is less than 4 k, which means that Ox equation gonna have two complex, distinct complexity, right? And then b squared is greater than 4 k, then we expect that there are two real root. So this is simple root, this is a double root. So double root means that in engineering, the spring force is equal to damping force. In this case also, we're not going to expect that there will be the vibration. So we see three cases in free mechanical vibration. And then how about the external forces acting on the object? So we assume the external force is given like this: some constant force times the cosine. Okay, so gamma is the frequency of the external force. So now in here, we're gonna so we see the we're gonna find out general solution, and then we're gonna investigate and when which value of gamma, this is gamma, right? Which value of gamma that the solution of this system will be exponentially increased so that it happened resonance. Definitely the gamma is related to the B, but not only B, but at F0 too. So see, in engineering, the gamma is a frequency, this is a frequency of external force. If this one will match some kind of the frequency of the object, then the resonance will happen. So we'll mathematically investigate that situation. So okay, so 4.9. So mass spring system. Let's see. So here we start from the think about the case one and 4.9. Okay, right here. The case one. So we see m y dou prime plus ky. So we just think about the undamped and free mechanical vibration. Okay. All right. Then y dou prime plus k over m, and then y equals. I mean, just I want to just wanting to make the coefficient y dou prime is 1, so we divide by m both sides. Implies. So let's say the omega. This omega is k over m, square root k over m. So now then, this is called that one is called the angular frequency. Okay. So this is now let's say this. Okay. then the equation can be written as y dot prime plus omega square y equals 0. So that omega is called angular frequency, actually. What is called angular frequency? Let's figure that out. So let's find out the solution. Okay. So we find the Ox equation, right? The Ox equation going to be r squared plus omega squared equals 0, isn't it? So which means that r is implies that well, r is a plus minus and I omega, right? So y that it means that y of t is equal to c1 times and a cosine omega t, right? And a plus c2 times sine omega t. Right? Yeah. So because we got two root in our Ox equation, even though these are complex root, so we can say the solution is a c1. Um, I mean, yeah, C1 cosine omega IT and sine omega t. I mean, so these are what? Actually, imaginary part and then real part and imaginary part, right? There's no exponential term. Remember that what I'm saying? Okay. So I think you understood that. So now, okay. So okay, that's good. But I want to just to analyze the behavioral solution. Probably it's much better if we express this one as one single term, one single geometric functions. Let's say this is equal to a times sine omega t plus pi. Okay, I want to rewrite this one as like this: some constant times single geometric function sine. Then it's much easier to understand the behavior of this solution rather than this, right? Um, how can get this from this one? How come? Yeah, so let's figure that out. So let's say because, okay, oops, so let's say C1 be A times sine pi. Can you say that? Yes, because the C1 is what? Is unknown, I mean, unknown constant in a relation, right? Will be determined by initial condition. So we can say C1 equals the constant times set a function of a constant or known constant. There will be no problems. So A times cosine pi 2. Okay. Then A times y of t gonna be what? A times sine pi and then cosine and then omega t and then plus a times cosine pi, right? And then sine omega t. This is omega, okay? Omega t. Yeah, so now use the addition property of trigonometric functions. Remember that sine cosine plus cosine sine is what? Yeah, sine pi plus omega t, right? So we can say a times sine omega t then plus pi. Okay, you know the formula, right? Okay, so because sine a plus b is equal to sine a and then cosine b then plus cosine a and then sine b. So now here a is called the amplitude. Now you see the amplitude of this the wave will be determined by this one, right? So that a is called the amplitude of the motion. It makes sense, right? And then the pi, this one will determine the pace. So this is called the pace angle. Okay, all right. Definitely omega is what? Determine the frequency, right? So that's why I told you the omega is what? Angular frequency. And this one, that is angular frequency. Anyway, so now let's figure out a. Let's figure out a, and we know omega, right? And then so let's figure out a and pi. So a gonna be, sorry, excuse me. I don't know why, but it's so kind of unstable. All right, so now a is gonna be what? Because it's to c1 squared plus c2 squared is what? This is gonna be a squared, and then sine squared, pi, okay, and then plus a squared, and then cosine pi squared. So this is equal to what? A squared, right? So which means that what? A is what? The square root. C1 squared plus C2 squared. Okay, and let's figure out the pi, the phase angle. The C1 over A is gonna be sine pi, right? Okay, because A is equal to you know, I mean, so C1 is A times sine pi, right? And the C2 over A is gonna be cosine pi, right? So combining them, tangent, which is what? Oops, sine over cosine. I don't know. Sorry. So why it's so unstable? The tangent pi gonna be what? C1 over C2, because the sine over cosine is the tangent, so tangent pi is just C1 over C2. Because we want to find out pi, right, using the C1 and C2, but pi is angle. So the graph of tangent, the direct graph tangent, right? So like this. So even though we figured out C1 and C2, we don't know which exact angle, because for this value, let's say C1 and C2 is over there, but there are not two, but multiple the angle, right? So we need to figure out which angle is correct for the specific value of C1 and C2. There is a way, right? So we draw the angle, sine of the tangent by looking at the sine of tangent. This is the first integrand, the second integrand, third integrand, and the fourth integrand, right? So now then, the first integrand, all the sine, cosine, tangent positive. I think you know about this, right? So this is C1, this is C2. Here the C1 is greater than 0, and the C2 is greater than 0. So pi lies, if C1 and C2 both are positive, then pi must lie in first quadrant. So pi lies in first quadrant. I means first quadrant. Okay. The second quadrant, C1 is negative, but C2 is greater than 0, positive. And then the pi lies in second quadrant. Okay. Similarly here, third quadrant, fourth quadrant. By looking here, C1 is less than 0, and the C2 is also less than 0. Here, C1 is greater than 0, and the C2 is less than 0. Okay. So angular frequency here. Now we got the angular frequency, right? And then here's natural frequency. This is omega over 2 pi. Okay. And then period is going to be 2 pi over omega, which is the reciprocal of natural frequency. This is flip the natural frequency, you will get the period. Okay. So angular frequency, omega square root of k over m, right? And the natural frequency is omega over 2 pi. The period is 1 over natural frequency. Okay. Let's see example. Okay. So I think we need some specific example to fully understand, all these stuff. So example 1, that is example 1 in textbook. Okay. So here's a wall. Okay. and some, small, the wagon is on the road. Okay. All right. So here the mass of this wagon is 1/8. Let me just ignore the unit. Okay. And then and that is initially positioned in 1/2, which means that here 0 is right there. That's the initial position, which means that y/0 is equal to 1/2. So that's the initial position. Okay. So, and then 0, that's the what? Equilibrium position. And then this wagon is, I think, a toy is attached on the spring. So what that means? It means that somebody or that one wagon or somebody pulled the wagon, right, outbound to the wall. Somebody just pulled the wagon from the 0 to 1/2 position. And then spring constant K is 8. Okay, spring constant K here. Yeah. Now, additional information, the that the problems give us is this: outward velocity. Okay, is a 2. What's the outward? That means the velocity toward that direction of this object is 2. Okay, and then we neglect the damping and the external force. Or external force. Then the question is this. So here's a question. Find the equation of motion in amplitude, angular, natural frequency, and period. Find the equation of motion in amplitude and angular and the natural frequency, okay, and period. Okay. So okay, let's find them out. Find them. Here's solution. Yeah, to figure out equation of motion, which means the equation of motion. What does that mean? We need to figure out y of t, right? Okay. So differential equation gonna be m and y dot prime, and then there is no damping force, so b must be 0, right? Okay, and then we got my dot prime plus ky is equal to 0, because no damping, no external force. And then the problem says the m is 1/2 and the k is 8, so we're gonna plug it. We're gonna substitute them into the differential equation. So the differential equation gonna be 1/8, but 1/8 y dot prime plus 8y equals 0. I don't like a fraction, so I just multiply by 8 on both sides. So we got this y dot prime plus 64y equals 0. So yeah, so that's the b, right? That is b. Okay, sorry. So now then the so here the omega is what? So omega is square root k over m. So which is square root of what? 64, which is 8. So we figured out angular frequency. That's the angular frequency. Okay, check. We got the angular frequency. Okay. Now let's find the Ox equation. Ox equation gonna be what? r squared, right, plus, and the 64 equals 0. So r is going to be plus minus 8i, right? Then that means y of t. So y of t is going to be what? C1 times, a times sine, right? And then omega t plus pi. So here a is what? C1 square root, C1 square, C1 square plus C2 square, right? Okay. So now then I didn't mention the initial condition. Let's figure initial condition. What? What's the initial condition then? To figure out this one, we need the initial condition and what? We need also your y1 of t is going to be c1 times the cosine, right? Cosine omega t, and the y2 is c2 times sine omega t, right? So we need to figure out c1 and c2. Then we can figure out a, the omega, and pi, right? So yeah, so then to figure out C1 and C2, we need to use the initial condition. Yeah, we need the initial condition. So what's the initial condition? Right there. Yeah, y of 0 1/2, and the y prime 0 is what? 2. Okay. So it means that y prime. So here, what? So y prime 0 is 2. Okay. So right there. So y of 0, y, since y over 0 is 1/2, right? Okay. So y of 0 is going to be c1 and then cosine 0, right? Plus c2 sine 0. So which means that c1, that must be equal to 1/2, right? So yeah, c1 is 1/2. And the y prime, this is 0, okay? This is 0. The y prime of t is c1 minus, right? Minus, and c1 times sine. Okay. The omega, what's omega? Omega is 8, right? The omega is 8 t, and then plus there is 8, right? Oh, I missed the 8 right here. The plus 8 times c2 times, and then sine cosine. Yeah, derivative sine cosine. The 8t. Okay. I just, here's, from there, what's the y? Y of t is what? T is a c1 and a cosine omega t. Remember that? c2 times sine omega t. Okay. So then, yeah, so we, that must be equal to what? And then we plug in 0, okay? So y prime 0 is going to be sine is 0 and then cosine is 0, 1. So we got a times c2. That must be equal to what? 2. So c2 is equal to what? C2 is equal to what? 1/4, right? So c1 is 1/2. The c2 is 1/2. Okay. Okay, now we are ready to find out a omega, a and pi, right? So here a is what? A is equal to square root of c1 squared plus c2 squared. Okay. So this is going to be square root 5 over 4. Okay, and the c, that's a, and then pi going to be what? Arctangent, right? And then 2. Okay. How come? How come? Because the tangent pi is what? C1 over C2. So what's the C1? 1/2. What's the C2? 1/4. So 8. 2, sorry. So 1/2 over 1/4 is 2. Yeah. So that's why pi is an arctangent of 2. This is approximately, but you know, that's going to be approximately 1.10715 phase. This is radian. Okay, so phase angle 1.107815 radian. Okay, and then from there, what do we have to add? 2 pi or 4 pi? No, because the C1, C2. I mean, because this is since the C1 and C2, C1 positive, C2 is positive, right? So which means that phase angle pi must be between 0 and 2 pi. Okay? So 1.10715 is between this? Yes. Okay? So now then that's why the natural frequency is going to be, so this is the pi, the radian by the way. So this is natural frequency. Oh, well, oh, sorry. So omega over 2 pi, so we filled out omega, right? So that's going to be 8 over 2 pi is a 4 over pi. Okay, and then we got pi, and then natural frequency, and then period is the pi over 4. It's going to be pi over 4. So we figured out everything. Amplitude, the phase angle, natural frequency, and the period. Okay, and then C1, C2, and natural frequency. So this is going to be A is, well, square root 5 over 4. Oops, square root 5 over 4. And sine, right? And the omega is just approximately 1 point, right? And 10715 approximately, okay? And the t plus omega. This is omega. Omega is what? What was omega? I forgot. Oh yeah, 8. 8t plus 1.10715. Okay. Okay.